Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syukri bin Abdul Rashid, and I'm gonna uh, present for our introduction. So, our assignment title is about soil contamination management. So, soil, which is referred as universal sink, suffers the greatest pollution among all the environment. So, this is because soil is the base of agriculture, either for us human or for animals. So the cause of this pollution is sludge, man-made product and treatment plant residue, and then we need to preserve this soil from being contaminated. Okay, therefore, we have proposed three technology. Okay, first one is bioremediation. So bioremediation it use microorganism to degrade and transform the environmental contaminant into less toxic uh, less toxic or less harmful. So it will use the bacteria or fungi that are obtained naturally, which they will produce enzymes that are responsible to attack the pollutant and convert them into the harmless product. So there are several types of bioremediation such as land farming, biopeeling, composting, and many more. Okay, next is phytoremediation. So phytoremediation it use plant or associate soil microbe to reduce the concentration of toxic in the soil. So this is a cost-effective environmental restoration technology because it uses plants, and in phytoremediation it can be classified into phytoextraction, phytofiltration, phytostabilization, phytovolatilization, and phytodegradation. Okay, next for the third technology is thermal desorption. So it is a method of treating hazardous waste contaminated soil by heating it to a high temperature. So the vaporized pollutant will then be collected using the air treatment pollution, and there are three general steps in this treatment, which is handling, material handling, post-treatment, and desorption.
Hi, Assalamualaikum. My name is Nur Afifah Fakih binti Zaki. So today I will present about the next technology which is bioremediations. So bioremediations are using in farming. This technique are involved with mixing the contaminated soil with hydrocarbon to improve the soil biological and physical factor, as well as chemical process for biodegradations. So the first impact for land farming is soil conditions. The soil conditions will regularly control to streamline the pace of contaminant corruptions. While for circulations, by cultivate the dirt with the foreordained recurrence, the dirt is blended and circulated air through. And for the pH, the soil for the pH should be within 6 to 8 range with a value of 7, which is natural, to being optimal. So with pH values outside this range prior to land farming will require pH adjustment and during land farming operations. And so pH within the land farm can be raised through the additions of lime and can be lowered by adding the elemental of sulfur. So the benefit of land farming is it is very low capital input required, and the technology is simple to implement and design. And the large soil volume can be treated in one time, and there are small environmental impact, and also it can lower the cost and the footprint. So the limitation for the land farming is, the first one is it is limited to removal of biodegradable pollutants, and the large treatment is needed. Next is it involved in risk pollutant exposure, and the substantial cost can be incurred during the excavations, and it also limit the microbial activity because of unfavorable environments. And lastly, it release the volatile organic compound in the environment. So, the cost for the land farming eh, in the range from 200 to 500 per cubic yard. Okay, this is the process flow of land farming. There are 4 stages. Started with the left, which is stage 1, and then stage 2, stage 3, and stage 4. I think that's all from me. Thank you.
So my name is Sadif bin Rosli, and today I'm gonna talk about basic cost analysis of phytoremediation process. Okay, so there are 4 basic components of BCA, which is impacts, benefits, limitation, and cost. And there are 6 points of each section. Okay, so the first section is impact. So the first impact is phytoremediation are available for remove, transfer, stabilize, and destroy contaminant in the soil and groundwater. It's also capable of mineralizing an organic substance, and then it also can reduce risk of spreading contamination. And it's also capable of remediating bioavailable fraction of contaminants. And then it also can eliminate secondary air or waterborne waste. And lastly is in situ application can avoid excavation and transport of polluted media. Okay, so the other one is benefits. So the first benefit is it is a permanent treatment solution, and then it's also required low capital and operating costs, and then it has potential to treat sites polluted with more than one type of pollutant, and then cost concerning high attention and request for future environmental cleaning strategies. And then it's also relatively easy to implement. And lastly, highly specialized personnel are not required to run the phytoremediation process. And then the limitation of phytoremediation is it's require technical strategy, expert project designer with field experience that choose the proper species and cultivar for particular metals and regions. And then it's also known as lower technique compared to the other technique, and it's also seasonally dependent. And then high contaminant concentration may be toxic to plant. And then it's also not capable of 100% reduction of contaminants. Okay, then the presence of multiple types of heavy metals and organic contaminants may pose a challenge. Okay, then the last one is risk of food chain contamination in case of mismanagement and lack of proper care. And lastly, I'm gonna talk about cost. So there are actually 2 main costs, which is the first one is capital and the second one is operating cost. So in operating cost, there are 5 type of costs, including cost of labor, cost of material, cost to use large machine, direct cost and indirect cost. Okay, so the first one is capital. So the total of capital is RM 142,466.52 ringgit Malaysia, and the percentage of cost is 46.02%. And then for operating cost, the first cost is cost of labor. So the total cost of labor is RM 11,413.51 ringgit Malaysia, and the percentage should 3.69%. And then for cost of material, the cost of material in total is RM 76,501.74, and then the percentage is 24.71%. And cost of usage of machine, the total is 3,388.69 ringgit. And the percentage shown 1.09%. And for direct cost, the total of direct cost is 41,070.05 ringgit Malaysia. And then the percentage is 13.27%. For indirect cost, the total of indirect cost is 34,764.22 ringgit. And then the percentage shown 11.23%. Okay, next I will talk about the process flow of phytoremediation. Okay, so the first stage is the selection of plant species and density, and then irrigation and soil amendment, then contaminant extraction, then degradation. After that, it will go to monitoring and then harvesting process, and then go through monitoring once again, and then the remediation is complete. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Elisa Adriana binti Hisham, and I will be explaining about the cost-benefit analysis for the thermal desorption. So, thermal desorption is well known as a physical separation process, and it is not designed to destroy organics. So, waste are heated to volatilize water and organic contaminants, and then a carrier gas or vacuum system transport volatilized water and the organics to the gas treatment system. So the bed temperature and the residence times are designed into this system will volatilize selected contaminants but will not typically oxidize them. So here is the table that I prepare for the CBA thermal desorption. So for the first column, which is the advantage and also disadvantage of this thermal desorption. So the advantages I have listed out 3, which is the first one is the time effective. So thermal desorption is the one of the technology that can be extremely fast. So depending on the type of soil and also contaminant condition, there is based on the research, it can be between the range of 20 and 160 ton per hour. So the second advantages is that the versatility of the thermal desorption is one of the versatile treatment method because it can be implemented either inside or also offsite. So the next advantages is that the soil recyclability. So thermal desorption is often used in the cases where the soil is being reused after treatment. Thermal desorption is also being called as an ideal system for the project because the treatment occurs on site and does not change the physical characteristic of the soil. However, for the disadvantage of this thermal desorption is that it requires evacuation. So it requires soil to be evacuated, and this tends to increase cost compared to the in-situ treatment strategy. The second one is that for the inside thermal desorption system, a large land area or footprint is often required. So this footprint is not only due to the system itself, but if the soil is not if the soil is not immediately being replaced, so the land will need to allocate for soil storage. And the last advantages is that pre-processing. What does it mean by the pre-processing is that it requires specific soil condition. The contaminated soil may need to be processed before entering the thermal desorption system. For example, for the pre-treatment, possibility includes soil sharing if the soil is agglomerated, screening or crushing if the soil has the large particle, and also dewatering if the soil have moisture content up to 20%. So the next column is about the total cost. From what I found, the total cost for the thermal desorption is around 14,600,000, 10,000 377.50 ringgit Malaysia. So the unit cost of inside remediation work treatment for 4,174 meter cubic of soil were estimated around 3,400 425.65 ringgit over meter cubic of the soil. The last column is about the impact of the thermal desorption. So the first one is direct fire. So fire is applied directly upon the surface of the contaminated media. So the main purpose of this fire is to dissolve contaminant from the soil. Through some contaminant may be thermally oxidized. So the second one is indirect fire. So what does it mean is that a direct fire rotary dryer heats an air stream which by direct contact dissolve water and organic contaminants from the soil. So the low temperature thermal aeration that has been developed by the Environmental Service Corporation is a good example of the indirect fire system which has been successfully used to remove DDT family compound from the soil. And last but not least is indirect heated. So indirect heated is an external fired rotary dryer fertilize the water and organic from the contaminated media into an inert gas carrier gas stream. So before I end my presentation, this is the generalized schematic diagram for the thermal desorption.
Okay, moving on to the conclusion. So, based on the CBA that we have conducted, so we can see that bioremediation is the most cost effective, then followed by phytoremediation, and lastly is thermal desorption. So the reason is because bioremediation is a simple technology, and also the microorganisms are available in nature. So the cost can be neglected here. Okay, next for phytoremediation, it requires expert personnel, and also we need to remove the toxic contaminant from the plant. And for the thermal desorption, it has high operational cost due to the heating for high temperature, and also it requires expert personnel to conduct the equipment. Okay, I think that's all for me. Thank you.